Hey, this is Don from Panlock Technologies again with another video. This time, got a question about rapid threat containment. Basically, what is the point of rapid threat containment? So I'm going to do some theory here. I did a video demonstrating rapid threat containment. I'm going to put it at the end of this video. I'm going to put a card up here, and I'm going to put it in the description. Now, before I get into the whiteboard and start discussing it, got a favor to ask. If you find value from this video, like I always said, please don't forget to share, comment, like, and subscribe to the channel. Tell a friend to tell a friend. I got a lot of videos on this channel for people to learn, and that's the whole point of my channel and building this community is to help people or be the help that I wish I had when I was coming up in the game. So with that being said, let's get to this blackboard here and talk about rapid threat containment. Now, first thing I'm going to talk about here, and I'm just going to do the abbreviations RTC here. Now, critical thing to understand. This is when ecosystem is going to be your best friend. Don't make the mistake that I see a lot of people making where they're mixing matching vendors because of dollars and cents. I get it. There is a budget. You might not have the CapEx dollars and all that good stuff. I get it. But if you want to start getting into these advanced concepts and stuff like that, you need to have an ecosystem that plays well with each other, right? It's like Apple or like Android. When you start trying to get an Apple device and then you got some Android devices that you're trying to work with the Apple device, not as clean in terms of integration. But if you have an all Apple ecosystem or all Android ecosystem, you see how they play well together. So with that being said, the ecosystem that I'm going to talk about is Cisco's ecosystem because that's where my skill set, my core competency is. So I'm going to talk about what you need to actually do rapid threat containment here. Now, Fortinet also has its own flavor of rapid threat containment. Now I do have actual Fortinet gear, so I am working on piecing that together and putting in a little demo about how Fortinet does it on their end. Now, I will not use anything like FortiAnalyzer or Fortinet. I'm going to use the on-board um, RTC capabilities on the FortiGate appliance using their security fabric technology and ecosystem there. But we're going to talk about the Cisco ecosystem. So, with that being said, what's a part of the Cisco ecosystem that does RTC? So, first thing, the most important thing in all this is Cisco ICE. So, you're going to have ICE. Okay. Now, you're going to have your switches down here. Cisco switches, Catalyst 98, 9000 series, whatever. And then you're going to have your devices plugged in. Okay. Now, we're also going to put an FTD over here. I'm just going to have in a box FTD. And we are going to do, I ran out of colors here, so I'm just going to do yellow. We're going to have SNA, Secure Network Analytics, right? This is all Cisco ecosystem, so this all comes into play. So what happens first is when devices plug in, radius, your typical radius situation is going to happen. They get accepted, and then ICE is going to have the session data. Now, via PX grid, ICE is going to send session data to both these appliances here. So you're going to have PX grid set up here. And this is going to share that contextual information, right? Now, everything in your ecosystem now knows the information that ICE knows. Okay, so ICE sends out the information to the FTD, also sends that information to, SNA, also sends that information to, and this is a brand new one. I'm going to slide this over here, and we're going to say PX Grid Cloud. Okay, which also integrates with things like secure access. Okay, this is where you can take your tagging structure, the whole concept of tagging with your TrustSec and all that good stuff, and you can now import that into cloud native um, enforcement points like secure access or multi-cloud defense or anything like that. And then you can create policies based on those tags and not subnet to subnet, right? So now you're basically taking that whole on-prem tagging TrustX structure and utilizing it into other things in Cisco's ecosystem. Again, ecosystem play is very important. If you had another piece of device in here, it wouldn't play as nice. So that's why do not make the mistake in just looking at the numbers and say which one is cheaper. I'm just going to go with that, right? Because at the end of the day, when you can't take some of these capabilities because you don't have the right ecosystem, now you're mad, and it could be a resume changing event depending on who you're talking to. So with that being said, the thing with ICE now, and they're going to be, I'm going to specifically talk about the integration with FTD and SNA, which is really Stealth Watch, but you know, Cisco marketing, they're going to call it something else. So it's now called Secure Network Analytics. So what's going to happen here is ICE has this thing called ANCs, Adaptive Network Control, right? Now, for my super old ICE and, well, I'll just say super old ICE engineers, it used to be called EPS, so Endpoint Protection Services. Now it's called Adaptive Network Control. EPS was like 1.0 stuff, and if you looked at the FTD back in the day with like the I would say like the 5.6 code, they had this thing called, I think it was PX Grid Migration, like version 1, I think. Yeah, I think it was called PX Grid Migration version 1. In the FTD now, it's called PX Grid Adaptive Network Control. So what this does is when you create these policies, it allows you to tag something, okay? Put a specific tag on a session. So what you could technically do is you would have quarantine, you can shut down, you could do a shutdown. Now these are all tags, it doesn't actually do anything. You had port bounce, and then you had reauth. Those are the 4 policies you technically can create. Now again, technically in the ICE world, this is just tags. All right. It'll tag your session with those specific ANC policies. What you do with them is based on what you do in your policy set. Okay. Now normally where this is gonna play into is your local exception rule. Most people are not going to use global exception rules because the difference between the two is when you use a local exception, it's local to that policy. When you use a global exception, it's basically global to all your policy sets. So all your policy sets would have this exception in there if you make it a global exception. Best practices, keep it local unless you specifically have a reason to be global. So what this allows you to do from an FTD standpoint, you can, we'll use green, you can create this thing called an instance and then a correlation rule. Okay. You create the instance to do the PX grid integration or to get the ANC policies. And then you do the correlation rule to say if you match, if something matches this, do this. Okay. And what the do this part is, it will apply or it apply one of these tags, any one of these tags you create to the session. And then a reauth to happen, which will affect something down here. Okay. It'll affect something right down here. So let's just say we do something called quarantine. All right. Let's say if you go to a certain country that we deemed is, not a good country in terms of cyber attacks. A lot of cyber attacks originate from there. Doesn't matter what the country is. And one of these machines down here, let's say this one, goes to that country. So the FTD will notice that as a connection event. So they will see it as a connection event. And basically, what you will do is it will say, if the destination is that bad country, what we're going to do is we're going to send ICE a message to read off the session because we got the session data where that came from, and then put this quarantine tag on it. So now when it reauths, and it sees the quarantine tag, and obviously the condition will be ANC policy equals quarantine. Then you say, all right, well, then I'm going to push a DACL down. Since we're talking about this, I'll push a DACL down. That's going to deny IP and IPv6, effectively kicking them off the network. Okay? That's the whole rapid threat containment theory or concept in a nutshell. You could do the same thing with secure network analytics. Let's say, now I'm going to use a different color. Let's say this machine was doing like command and control, exfiltration, some nonsense. And then now in SNA, it's a little different. You got to create the rules. You can create rules for this. But let's say you were in the portal per se, and you saw that. Well, then now you'll have that context information from the PX grid integration, and you can say, oh, this machine is doing something bad. I'm going to apply the ANC policy again with quarantine, and then it will kick off the workflow to ICE. ICE will look at that session that now needs to be re-auth, but has applied the quarantine tag to, so it has the quarantine tag to, and then you push a DACL down to this because your exception says always push this DACL. Another DACL to deny IP and IPv6. This is rapid threat containment in a nutshell. So now the FTD one is a little bit automatic compared to, secure network analytics, but that's why you would do this. Now you see here where everything plays together because we're all in the same ecosystem. We have Cisco switches. We're using Cisco ICE because that's the brain of our security architecture. And then we have our other things that play within the architecture as well, which is our FTD. And then we have secure network analytics also playing in part of this ecosystem. And you can even do, if you want to play, secure endpoint, right? So you can create rules for secure endpoint. Now you can do this on the FTD as well, because this is the whole network as a sensor concept. If you ever hear somebody say network as a sensor, this is what they're talking about. The FTD is a sensor. Once something comes in there, once something comes in there, if it's deemed or if the disposition is bad, anything connected to your fabric, really, network as a sensor fabric, if you have multiple FTDs, now when you mark that the disposition is bad at this site, it will also mark the disposition somewhere else that never seen this new file that came in or whatever came in. It will also have the information to say, hey, this hash, right? Because it's technically a hash, is what the disposition is actually looking up, right? This hash is bad, and we saw it on the sensor over here. So if you ever see this sensor coming through over here, even though you never seen it, but if it ever comes over there, you already have to block it. You need to block it because we know it's bad because of some other site that's seen it. Same thing with secure endpoint. If some people, some malware gets on this device and it gets quarantined, all the other devices will now will now have the disposition to say, if you see this hash, quarantine it immediately or block it immediately. That's the whole point of the ecosystem play, right? Now, this will not work if you had a Palo at the edge, you were using Forescout as your security appliance, you were using Juniper switches down at the access layer, and you were using Forta Analyzer as, your telemetry kind of thing, the telemetry monitoring. See how that doesn't work? But I've seen environments like that because, oh, it's cheaper to go with Forescout. Oh, it's cheaper to go with this. Oh, it's cheaper to go with that. And then now you have siloed pieces of technology in your environment that they don't talk to each other. So now they don't talk to each other, so they don't play nice. So you can't kind of get this rapid threat containment philosophy going, right? And then on top of that, you need specific pieces of knowledge for each one of these different things that play into your security architecture, right? So you may have a specialist on the FTD, specialist on 40, specialist on Forescout, specialist. You're not going to find a specialist that knows everything. So now you got two different teams with two different objectives talking to each other. And that's a battle that I see all the time. This team doesn't agree with this team because you're making this team's job harder, even though you're making your job easier. and they don't want to make their job harder and your job easier. So that's where you start butting heads. Now, what is the purpose of all this really? Now, I might hit this button. It might ask me to pay for something, but let's see. Oh no, actually it didn't do it. So, all right. So, what's the purpose? So, the purpose of this really is about response time. Let's look at what happens in the normal situation. So, let's say incident happens. Incident, unknown incident. Then it has to get logged, right? So our devices see it and they got to log it. Then it sends that log sends triggers an alert. All right, triggers an alert. Now someone needs to see the alert. Someone someone sees alert, then investigates. I'm gonna say I investigates, then does something. Does something. All right. So by the time you get from here to here, all this needs to happen. All right. All this needs to happen. And while all that's happening, this original incident, that the original IOC or incident of compromise, is now probably extrapolated. Like you probably expanded it, right? This might be one device, right? By the time you get to actually do something, this, depending on what it is, can go from one device to, depending on what's in your environment, hundreds of devices, right? So now you got a problem because there's a huge amount of, look at the time, huge amount of time from detection to remediation. This is how malware ends up spreading because of this. That time between detection and remediation. What RTC does, it shrinks down that time, because soon as the incident happens, right? As soon as the incident happens and is detected, now this is very important. A lot of people spend a lot of money on this part, remediation, prevention, stuff like that. But they don't spend a lot of money on that part. This part here, detection, is the most important. You know why? Because if you can't see it and you can't detect something happening, you ain't going to have any time to do any of this. Right? This is not happening. Right? And the protection stuff is all hypothetical until something happens. You might think you have the proper things in place to protect yourself from stuff. And then when something happens, you're like, oh crap, all the stuff that we put in place that we thought was going to protect us actually didn't work. Right? So, and I've seen that happen, unfortunately. I'm laughing, but I've seen that happen. And people, that was a rough day at the office, so to speak. But detection, being able to detect something and then do something about it automatically. So detection, and if you have auto, mechanisms in place to take an action, a la RTC, you shrink the time down from incident log alert. Someone has to see the alert. This one is the big one here. Someone has to see the alert. What if it happens at 2 o'clock in the morning? You have to wake someone up. Wake someone up, right? Unless you got like a 24-hour like sock or something like that. You gotta wake somebody up, but it's still someone has to see the alert and then investigate, right? Investigate and then do something, right? All while they're investigating, they might do something like, okay, let's go back and let's find this device and hurry up and shut it down. But by that time, it already moved laterally. So now you're dealing with issues. But again, back to detection, most important, right? So what RTC does, this kind of is the auto mechanism, but it also does the detection part somewhat, right? Now the detection part, obviously, the thing that's going to do RTC needs to see the traffic in order to do it. But once it detects it, it automatically takes an action based on what you do, what you want, right? Based on what you specify it to do. In the Cisco world, this is where the tag, quarantine, immediately shut it off the network, right? Which is a lot faster than what you see up top here. Logs, see it, alert, someone sees it, you go do something, then you shut it off of the network. All right. So that is RTC in a nutshell and the benefits of RTC. Again, the biggest key takeaway you can take away from this is ecosystem. Make sure your ecosystem plays well to allow you to do this, right? If you have different technologies, you're going to have to string it together manually, and that can be a pain in the butt. Different API, this, that, and the other. It may not work because the vendors don't want to talk to each other. They purposely made it so anything outside that ecosystem doesn't talk to them as well. Again, depends on what your security architecture is. But again, with RTC, and at least in the Cisco world, if you have all Cisco devices and ICE is the security brains of your security infrastructure, you can kind of put these things in motion and in play so that you can see, hey, if something bad were to happen, at least have some automation involved that would, decrease the threat or the blast radius when something bad does happen. Now, I hope you got, value from this video, understanding the theory of RTC and why it is important to try to implement it into your network or your security architecture if you can. Now, I did do a video on rapid threat containment. I'm going to put it up here or up here somewhere. Watch that video now that you know the theory. So now you'll see it in action. And then, if you like that kind of stuff, watch the other videos as well. I'll also put a link to that same video in the description so you don't have to wait all the way to the end right now to get the link to the video. Hope you liked it. Once again, this is Don from Padlock Technologies. If you haven't subscribed already, please don't forget to share, comment, like, and subscribe. Tell a friend to tell a friend. Hope you enjoyed it. Thank you and have a nice day.